Hello again. This version of, or video, should I say, not version, I'm going to talk about Hot Standby Routing Protocol, Hsrp. Go through why we need it, configure it, show the system working, hopefully, and go from there. So what we have at the moment is two routers on a LAN. All of this is set to VLAN 1. Haven't changed, put any VLANs on this. I've got a core layer, distribution and access just for the hell of it. Don't need that, because most of our stuff is actually going to happen between these two routers on the inside. With Hsrp, sorry, we're not really bothered about the outside too much, but we still need to know that we can route and get stuff back in and out. So yeah, we'll talk about Hot Standby Routing Protocol. Play around with it, have a bit of a fiddle, see how it goes. Okay, so why do we need it? So pretty much if we've got one router going out, then should it die, we would like to have a backup path. There it is, hot standby. So it's redundant, can just sit there and do nothing until this one dies. We can, if we like, put another VLAN onto this one. So there's things we can play with, but at the moment it's not a load balancing protocol, but it just sits there, and should one fail, the other one will kick in. Now let's have a look at the kind of major issue here. So if we pop onto this PC down here, and I have played around a bit before, so we might see some old pings and all the rest, just to make sure it does work. Now if I do IP config, at the moment my gateway was set to nothing. Gotta love that. Okay, that's good. So let's hop in. So my IP address on here is 192.168.1.10, pure C class, and I'm going to use this router on the left, router 1, as my gateway. So 192.168.1.1. 192.168.1.1. Ooh, it's a good typing, isn't it? So should be able to ping out and back in. I've set up routing just using static routes out there. So let's have a look and see if things actually work. We'll do an IP config again. Yep, that's a bit better, isn't it? So let's ping our gateway for a start. So 192.168.1.1, and we got a reply from him. And I'll ping the address .2 outside. So outside our router, this is the 1 and 2 network. And let me ping my server right out here, 220.20.22, and we're getting a response from that. So that's all well and good, but should this link die internally, or this link on the outside, what's going to happen? This router, as our gateway, won't be able to work. So we need to have some sort of method, some way of allowing this router to fail and then this one to take over the responsibility. And that is called Hot Standby Routing Protocol. And we'll need to hop in and actually just do a little bit of configuration just to see how the whole process works. So I won't kill too much stuff outside. I'll kill stuff inside later on just to test it. So let's hop in and configure this. Okay, so we're in our CLI there, already in config mode, which is nice. So let's hop onto our interface. So interface gigabit 00 is our internal one. At the moment I'm just using the physical interfaces. If you were to have VLANs in here, you would have to go onto your sub interfaces to do the same things, and it's worthwhile actually playing with that just to do it, I think. Anyway, I've got an IP address on, and I've got my interface turned on, and it's quite simple actually. We just type in standby, so no Hsrp, just standby. The first thing we want to do, if you put a question mark in, is actually do the version number. So 2 version, by default I think we're version 1. Version 2 is what we want. It does solve a few issues. Not a lot, but yeah. Whoops, I put a 1 there, didn't I? But the thing is, version 2, too much talking, not enough thinking, eh? Now you need to run both the same versions at both ends. They do use different multicast addresses to actually connect to each other because they do chat. It's a protocol that chats, everything works. Okay, so far so good. So we can go in and put different things in here, priority levels and all the rest. But what we want to do is actually create our own group number either side. So the only thing we do outside of group number at the moment is just version, like we've done. Next one we do is we go into standby, and I'm just going to use a number 1 here. Now we've got 4,096 different values to choose from, so just standby 1 will do it. And we have to use the same number 1 at both ends. So in here, you can see it's pretty much the same as what we had before. So we've got IP, so we enable Hsrp and set a virtual address. IPv6, same deal, but for IPv6. The other two we're going to play with are preempt and priority. So standby 1, let's put an IP address in there. I'm not using IP6 at the moment. Now what we're going to do is put in just a virtual address. Now this is the address that's going to be our gateway down here. So go back. 192.168.1.254 is now going to be my virtual address, and it'll have a virtual MAC address. It'll float in a way between this router and that router. So they'll actually share the address. But what we want to do is say, well, I want this router on the left to be, it's all popping up, isn't it? To actually be the one that comes up all the time. So I will need to change my priority. So for standby 1, my priority is going to be a number between 0 and 255. The default is 100, and if you've got a number over 100, then this will be the default router when our IP is 192.168.1.254. So if you keep your default route at 192.168.1.1 or 1.2, it'll still use those actual physical interface addresses, but we're using a floating address between the two routers. Now I remember reading somewhere that if one fails, then the priority number goes up from 100 to 105, or 95, sorry. It keeps getting worse. So the more failures you have, the more it chops it, but a bit beyond the scope of this course. Okay, so we set our priority at 150. So once we've configured the other one and they've negotiated, then this one will be the default route. Will come through here from the inside, nothing from the outside. That'll be debated later on, and that's good. So that's what we want. Now the other thing we want to do is put a standby 1 and preempt. Now what preempt says is, if this is my default router, router 1 on the left, and it dies, then router 2 will become my default gateway. It will take over the IP address of 192.168.1.254. And our switches, and I invite you to do this on a physical network, you can do it in here as well, but do it physically. The switches will switch based on MAC address, so the MAC address will actually move from this router for the IP 192.168.1.254 across to router 2. So Hsrp has one virtual MAC address, and the switches will switch traffic based on that. Now, back to preempt. Sorry, I digressed there a bit, didn't I? So standby. Preempt says that if router 1 dies, then router 2 will take over. If router 1 comes back online, then this preempt says dump router 2 and head off over there. Now, in packet tracer, it does not give us an extra option. However, there is in physical stuff a bit of a delay you can put in. So if you're not too sure if this is going to be up for a length of time, you can actually put a delay in there to say, well look, I'm not going to send it back to you until you've been up for 5 minutes or something like that. So you'll put that beyond here, but it's not in here, so we'll just leave it at preempt there. So let's have a look at what we just typed in. If we show running config, so on our interface gigabit Ethernet 00, we've got this physical address. It's turned on, so normal interface stuff. And then we said, okay, we're going to use standby version 2, and then we're going to go standby 1, and we can create an instance of 1, so we've got 4096 of different options there, and we're putting a virtual interface on. We've said our priority on the left-hand one is going to be higher than the default, which is 100, and our standby 1 preempt is telling us that should this router fail, or have this path fail, then this router 2 will take over, and when router 1 comes back up, it will take over the default IP, so 192.168.1.254. Okay, so let's go on to router 2 and do a similar set of commands into there and see what we need to do. Okay, so configure terminal interface gigabit 00, and at the moment, so do show IP interface brief, our address is 192.168.1.2 and our interface is up, so let's go into standby. So standby, first one, version 2, so that they're both the same. Standby 1, and our IP is going to be the same virtual IP address. So 192.168.1.254. And here's our group 1, so that's our group there. Hsrp, state change, initialized. Now, we don't have to, put in, oh, nice, so we are standbying, so it's having a chat there. Complete, good. Standby 1. So we don't have to put in our priority level because by default it's 100, which is lower than router 1, which is at 150, and we only need preempt once. So we're done. We're done on this side. So let's have a quick look at our show run. And come back. Standby version 2, and our standby IP is it as far as we're concerned over here. So if I show standby as an option, we can get a brief or gigabit Ethernet or whatever, but let's just show standby, and the state is in standby, group 1, version 2. So if you need to troubleshoot, make sure you're on the same group, make sure on the same version. Here's our state, which is what it should be, and there's our IP address, 192.168.1.254. Now the active virtual MAC address in there, at the moment it's actually the same as our local. Okay, so let's go and have a look at router 1. So Control Z. So if we chose standby, then it's active, not in standby. There's a number of state changes that have gone through, but again, group 1, version 2, there's our IP address, and there's our MAC address. So is that MAC address the same as we had for, we're going to see a lot of garbage behind here, aren't we? Whoop, here's the one we want. If you'll notice our MAC address, quadruple 0, OC, move this one over. So quadruple, that's 0, OC9F, F001 is the same as the MAC address at the other end. Good. Let's get that back. Okay, so it should be working. So let's go onto my PC, and at the moment my default gateway is incorrect. It'll still work, but let's put in 254 and kill that, and we'll pop onto this PC over here as well, so the correct the gateway that we want to play with, 192.168.1.254, is the virtual IP. So it'll float around between those two routers. So let's make sure we can ping. Now this one hasn't pinged yet in this video. I've pinged a few times from there, so there might be some other stuff, but let's go. So let's ping 192.168.1.254. Well, that's good. Let's just check out what its MAC address is. So Hsrp-A, and there's that MAC address again, same one. So it's a virtual MAC address. Let's ping outside, and this time let's go into simulation mode actually, and let's ping 220.20.20.2 and have a look at the path that everything takes. So I've set this switch as the root bridge, so using your spanning tree makes a bit of sense to have one of these two as the root bridge. If this is the default exit, then the root bridge of the switch connected to it does make a bit of sense, and everything goes through there and we're happy. All is well with the world. Okay, so let's kill something in there. Actually, what we can do, let's just have a brief look at our MAC address table here. Show MAC address table, and out of port FA01 we've got this address, 40OC9FF001, and I'm pretty sure that's our guy. Yep, there it is. So that's the virtual MAC address out of this port. This is FA01 up there. So we can kill the router, but I've got to rebuild all the configs if I do that. So I will kill that interface there. Now what should happen is this router should take over as being active. Previously it was standby, and now we've got a nice, just perfect timing. State change, gigabit 0, group 1, standby to active. So let's just show standby. We'll do brief option this time, just to see. So there's our virtual IP. Our active is local, our state is active, our priority is 100, group 1, and that's our gig interface. So let's ping from this guy down here now. We'll do the same ping as we did before and see which way it goes. Perfecto, and off it goes through there. And that's a bit sad. It's going to die there, isn't it? And that's my problem. That's a routing problem. That is the trick with this whole thing, is we've got to get data back in this way. So we have to tell that router that this interface is down. And I've got static routes in there. So if we had a dynamic routing protocol running to that router and back down, then we wouldn't get this nice little routing loop, because this one will not advertise this network, and that will become the better path through here. So using your different metrics and load balancing gets data back in. Nice little exercise to get that working should things fail. So fail the outside connection, fail the inside connection, fail the router, and make sure that this still is used as an exit interface and through. Excellent. Well, that's good. So the ping failed, or should fail. And we'll just kill it there because it's going to just sit there. And that's just about it, except for one thing. Let's just add our connection back in. I haven't even got trunking running on here. This is all just plugged in. And we'll fast forward time a little bit. And if we click on that one again, we'll see we've got a state change, that it's gone from standby to active. And that is the preempt saying, I want it back. I am the main geezer on this patch. You go away. And it's got to change back to standby. So let's have a look at show standby brief there, and its state is standby. Because preempt is not set, and because its priority is lower, it should always be standby, but all well and good with that one. Okay, there's Hsrp, done. We've got the show commands, show standby and show standby brief. We've put in version 2 at both ends. Version 1 will not talk to version 2. They use different multicast addresses to actually communicate. We have the same standby group number between the two, and we've got the same IP address as the standby IP, and that becomes our default gateway, this virtual IP address. The switches will sort out MAC addresses in here through the negotiation. So when this router becomes active, then it's sending information through the switch network to say, well, that MAC address that we had now lives on this router, and you've got to send it through that port there. Actually, we can. No, we won't be able to show that now because it's moved back. Now, a few things that you should have a play with. Play with multiple VLANs and have router 1 as the gateway for one virtual network and router 2 for another virtual network, just to see. You'll use different group numbers, obviously. And the other one is to get routing working out here. Now, if you're just running RIP, ERGRP or OSPF, actually don't use RIP, please. OSP or ERGRP through there, then everything will work fine. You could try BGP as well, actually. Because this route, when this interface here dies, then this router will not be advertising this path to the 192.168.1.0 network. So this router will only have that path to play with. Now, when traffic comes back, do we want it to go both ways and load balance, or not? Do you want it all to come through a particular path? Now that comes down to your costs of your serial links. If you've purchased a better serial link on the left, and that's where you want all your data to come down, then you need to chat with your ISP and get a bit of load, or change your metrics down this path for OSPF, and you should know how to do. Actually, you might not know how to do that, but later on we'll play with that. I'm trying to think what else to play with. Oh, the other one to test out, sorry, is if this link dies between router 1 and our ISP router up here, Hsrp is still running internally here. It's quite happy for this to be our default gateway. Where would you send traffic? You want to send it through there. So you still want this to be the default gateway, but traffic is going to come back and down, and you want it to go out here. So if this link outside dies, then get traffic happening down this way. Now it's not too hard to get traffic coming back there if that link dies as well. And again, changing your metrics and things like that. So things to play with, but that's the basics of it. So thank you for listening, and we'll see you next time.